You know, keeping things clean can take a lot of work. But from a physics standpoint, what is work? Well, we're about to learn.
Well, aloha everyone. Today we're going to talk about work and power. So, what is this idea of work and what is power? Well, in order to do this, we need to think about work first. So, work is going to be a dot product. Work is a scalar, which means it doesn't have a direction. And it is going to be equal to a force vector dot product with a displacement vector. So sometimes you'll hear this as force times distance. That's not quite right. It's force dot product displacement. When we do that, that's going to be equal to the same as saying the force times the distance times the cosine of the angle between those two things, between the force and the displacement. So, in this case, let's say that we have a car. And we decide we're going to push on that car. So, we push the car with a force directed this way, F. And maybe the force is going to be 100 newtons. And maybe we're able to get this car to move a distance or a displacement. The displacement is going to be to the right as well. And it's going to be equal to, I don't know, how about 10 meters? How much work have we done? Well, the amount of work we've done is equal to the force dot product with the displacement vector, which is equal to 100 newtons. Actually, I should do it this way first. It's the force times the distance times the cosine of the angle between them, right? So that's equal to 100 newtons times 10 meters times the cosine of, well, in this case, it's to the right for the displacement, to the right for the force. So since those two things are acting in the same direction, the angle between them is 0 degrees. Cosine of 0 degrees. And it turns out if you know your trigonometry well, you'll remember that the cosine of 0 degrees is just 1. So if they're in the same direction, it's the exact same as just multiplying f times d. This is going to turn into a 1. But if they're not in the same direction, if that's anything other than a 0 degree angle, it's going to be important. 100 times 10 is going to be 1,000. And it's going to be Newton times meters, or 1,000 Newton meters. Now, it turns out 1,000 Newton dot meters is going to be given a name. And we call this unit, ooh, that's terrible. We call this unit joules. So this is 1,000 joules. So we have done 1,000 joules of work.
So as I clean here, I'm doing work because I'm putting a force on this cleaning pad. It's moving for a certain displacement. And there's an angle between how I'm pushing it because it may not be directly in the direction. Usually I'm pushing down on it, maybe at an angle to keep it in contact with the car. So, as I do work cleaning this car, there are some important things that we need to consider. First of all, if you take an object and you push on it, but it does not move, the displacement is 0. Therefore, the amount of work done is 0. Second, if an object moves without you putting a force on it, you have done no work because the force is 0. Finally, if there's an object moving at a 90-degree angle to the way you're pushing something, so let's say I push this way, and for some reason it slides that way, then that object you are not doing work on, because the cosine of the angle is also 0. So here I have a 5 kilogram weight. If I lift this 5 kilogram weight a distance of 1 meter, I have just done work. And the amount of work I have done is going to be equal to the force dot product with the displacement. Now the force I used to lift this 5 kilogram weight was probably around 50 newtons. The displacement was 1 meter, and the displacement was upward, and the force was upward. So therefore, the angle between them is 0 degrees. Force dot product with displacement is the same as saying force times displacement's magnitude times the cosine of the angle between those. So 50 newtons times 1 meter times the cosine of 0 degrees equals 50 newtons times meters, which would be joules. So in doing this action, I have just done 50 joules of work.
So what's the idea of this thing called power? Well, power is going to be, we're going to use the letter P for that, and that's going to be defined as the amount of work we do divided by the amount of time it is done in. Sometimes you'll see a delta T there, but it's really just work divided by time. It's how fast are we doing work. That tells you the power. So something with more power can do work faster. So for example, let's say in this problem here, we did this whole process. The time was, I don't know, let's say it took us 20 seconds in order to do this. Well, we already know the amount of work we did was 1,000 joules. So this is going to be 1,000 joules, divided by a time of 20 seconds, which is going to be, that's the same as 100 divided by 5. I think that's 20. No, 100 divided by 2. I think that's 50, right? Because yeah, 100 divided by 2 is 50. And then work over time, that's going to be joules per second. We are doing 50 joules of work every second. If we did work faster, that number would be higher. Now this joules per second thing, again, we give this a nickname, and we call this 50 watts. Or just 50 and a capital W here. So, if you've ever looked at something like a light bulb that was measured in watts, that tells you how much work that light bulb can do in 1 second.
Power is equal to the amount of work done divided by the time. So that means I can increase my amount of power by doing one of two things. Either I can do the work faster. So instead of lifting this slowly, where I would be using a small amount of power, I can lift this quickly, which takes a lot more power. Secondly, instead of having one weight, I could have 3. If I did, that would mean I'm using a bigger force, which means more work. Even if I took 10 seconds to lift it, I'd still have a greater power because I have more work.
So that's really all there is to it for work and power. Mahalo for watching, and see you next time.